Okay, now we're going to find coefficients. So when you have binomial coefficients, you'll see that they appear with brackets in NR, or you will have factorials given, or you may see a C. In general, you're going to be given the bracket and you need to use this rule here, okay? So if I ask you to find 7, 2, it's made up of 7 factorial, 2 factorial, and the difference between them. So that's 7 factorial, 2 factorial, 5 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, over 2 times 1 times 5 times 4 times 3 times 2 times 1. You can see they cancel and you get 7 times 6 over 2 times 1, which is 42 halved, which is 21. I wouldn't write all of that. I'd write this first two parts the same. You can write times or you can just write them beside each other. And 7 factorial means 7 times 6 times 5 factorial then. Then what we can see is that the 5 factorials cancel out and you end up with 42 over 2, which is 21. You can cancel the 2 and the 6 down as well. If you see anything with combinations, it's the exact same process. So we use this in probability and statistics and in another math-related topic called combinatorics. Okay, and the topic is not covered in this course, but the term indicates the number of ways you can choose R out of a total of N, okay? So if you were asked how many ways you could get 2 chocolates out of a box containing 20, you'd see it like that. But it's just exactly the same as that. So we're always focusing on this idea here. It's 20 factorial over 2 factorial and the difference is 18. I'm not going to write a big long screed at the top. It's 20 times 19 times 18 factorial. And then do you notice that the 18s cancel? Actually, 2 and 20 reduce down to 10 as well, and you end up with 190. You can pause this just now and have a go at these ones here. I'm about to go over the answers. Okay, so it's 5 factorial over 2 factorial, and the difference between them is 3. You can see that the 3's cancel down, and you can see that the 2 and the 4 can reduce down, so you end up with 5 times 2, which is 10. 6 factorial over 4 factorial, and the difference is 2. What you notice there, that the 4's cancel, the 2 goes into 6 3 times as well, and you end up with 3 times 5, which is 15. And then 5 factorial over 3 factorial, and the difference is 2 factorial, so that's 5 times 4 times 3 factorial. You'll notice the 3's cancel down, and the 2 goes into the 4 twice, and you get 10 as well. What about a wordy one? How many ways can 4 pupils be chosen from a group of 7? That's 7 4 then, which is 7 factorial over 4 factorial, and the difference is 3. 7 times 6 times 5 times 4 factorial. You notice that the 4's cancel down, and then you can also see that the 3's, 3 times 2 times 1 is 6, can cancel as well, okay? 4 should cancel down, there we go. Okay, so what you're left with is 7 times 5 is 35, okay? Right, what you'll see from question 12 and 14 is 5 2 gave you 10 and so did 5 3. So that means 5 2 must equal 5 3. 6 4 is 6 factorial over 4 and 2. So what's the partner in crime? If I went to 6 2, you'd get 6 factorial, 2 factorial, and the difference is 4. It's the same combination in a different order. So you should be able to see that the 4's cancel down, and in fact, so do the 2 and the 6, okay? So I've not cancelled down the 2 and the 6. You could do 30 over 2 is 15, or you can see that 2 goes into 6 3 times. So they're the same answer. So notice that that gives you the same answer, and they give you the same answer. So there's a relationship there. Okay, so we're going to prove it. I'm going to show you 2 ways to prove it. When you go to prove something, then you could start with the left-hand side and prove if it becomes the right-hand side. So NR is n factorial, R factorial, and the difference. But what we're actually looking for is to end up with n minus R on this side here if we were going to write this in the same format. So what I'm going to do is just switch these around. That means that because that's n factorial, that'll be n minus R. I've got that in the right part now. The next thing is that I need n factorial, n minus r factorial, and the difference between them over here. So I need to create an r somehow. N. So I'm going to write r and replace it by n minus n plus r because I need n's in there somehow. They cancel out, so that will work. So that means that if I put that in there, how do I get n minus r? I need to pull out a common factor of -1. So by doing that, then you get the n minus r. So all I've done is pull out the minus to create that. Now let's look at it. That would be n factorial, n minus r factorial, and the difference between them factorial. I've done it. That actually goes to n minus r, which is in fact equal to the right-hand side, and I've proved it's true. There's an easier way to do that. If you try to consider the left-hand side and the right-hand side separately, the left-hand side will just be your normal n factorial over r and the difference between them factorial. If I go to the right-hand side, that will be n factorial over n minus r factorial, and the difference between them, don't forget a bracket around that. So when you open it up, it's n minus n plus r. What you'll see is the n and the n cancel out, so you end up with r. And then if you just switch the bottoms around, it's actually the exact same. Isn't that easier? So the left-hand side equals the right-hand side. That means this rule is true, and we know from earlier that they're true as well. So if you have the number at the top, then whatever the partner is to make that number will be the same value. So 7, 4, the partner will be 7, 3, and 21, 17, the partner will be 21, 4. Also, you've got values for 10 that we've calculated. 5, 4 has got a value of 5, and 6, 4 has got a value of 15 that I calculated. What you'll notice is these will add to give the same value. So there's another rule in here, which we call the second binomial coefficient rule. I've made a mistake with the t there, but I'll go back and change. Right, so I've changed it here. Okay, so let's try and prove this. The easiest way is to try and get a common denominator. So if I go for the left-hand side first, that'll be n factorial over r minus 1 factorial, and the difference between them, that one's okay. Remember, if you've got a combination factorial, to put a bracket around it. Let's open that up. So it's minus r plus 1. Now, before we go any further, remember the whole aim here is to get a common denominator, so somehow I've got to get these to be the same. And if you recall from before, you know how to represent factorials as what it is with the one below it factorial. So this is an issue here. So I need to get r's similar, and I need to get n minus r similar. So what I want to emphasize is that n minus r plus 1 factorial can be n minus r plus 1 times 1 less than it factorial. So that's what I'm going to do here. So that's n factorial over r, and this is n minus r plus 1 times n minus r factorial. And r can be written as r times r minus 1 factorial. Why did I do that? Because we're trying to get a common denominator. Do you notice you've got an r minus 1 factorial and you've got an n minus r factorial in both now. So let's pull out a common denominator. Both have n factorial in the top, and both have r minus 1 and n minus r factorials in the bottom. That leaves me with 1 over n minus r plus 1 in the first one. And then we have 1 over r here. Common denominator, remember, let's multiply the bottoms, cross, cross. So I've just brought the r to the front there, cross, cross. What do you notice there? Do you see that the r's actually cancel out? So we end up with n factorial times n plus 1 at the top. At the bottom, you'll see I've brought the r beside the r minus 1 factorial and the n minus r plus 1 in front, because in blue, that is still the exact same, and in green, that is the same. So that can then go back to n minus r plus 1, and that can go to r factorial. What do I have to do next? Well, one other thing, n factorial was at the start. I put it to the end, so you can see it's this combination here. So n plus 1 times n factorial is the same as n plus 1 factorial. And I'm going to change this so that I've got n plus 1 at the start. Why have I done that? So you can see it's n plus 1 factorial over r factorial over the difference of the two. So it is in fact n plus 1r, which is in fact the right hand side, and I've managed to prove that the rule exists and is true. Nice. You might have to prove this, that's why I'm going through it. Okay, so if you know that you've got 8, 6 and 8, 7, that will go to one higher at the top, 9, and the largest 7. So what's one higher? 15, and the largest is 12. That's it. One higher, largest, one higher, largest, one higher, largest. Okay. Right, lastly, finding n. Think you'll like this. Right, so that's n factorial over 2 factorial and the difference between them. What would you do next? N minus 2, you need to create it, so that's n times n minus 1 times n minus 2. They can cancel, so you've got n times n minus 1 at the top. 2 factorial is just 2, so you could cross multiply. Let's open it up to n squared minus n and bring the 30 over, always making sure it equals 0. Then factorise. Make sure the larger one's negative to get the minus n, but then remember it says positive integers, so that means that finally you know n has to be more than 0 and n equals 6. Let's do one more. This will be n minus 1 factorial at the top over 2 factorial times n minus 1 take 2 factorial. That bracket in there becomes n minus 3 factorial. So that's the denominator. I'm doing that first this time to show you that's what I'm aiming for at the top. So it'll be n minus 1 times n minus 2 times n minus 3 factorial. Then what we should notice is they'll cancel out. So we get n minus 1 times n minus 2 over 2. So I could cross multiply by 2. That's n squared minus 2n minus n plus 2 equals 90. N squared minus 3n, bring it over, is minus 88. Remember quadratics always set equal to 0. 8 11s, remember to get negative, it will be minus 11. So then you get minus 8 and 11. As n is more than 0, n equals 11. Okay. Right. What are you going to try? You're going to try ones that have finding n, that's probably your trickier ones, and then actually up to 30 is all just revision of everything you've done so far. So you'll find that if you open up the Scholar PDF, you'll go 20 to 38 on page 8 and 9 of the PDF, and you can find your answers in 2, 3, 7. Okay.